Hello everyone, welcome back. Previously, we have learned about consumer's utility function and the budget constraint. Now, we can begin to analyze how an individual consumer makes decisions. For a rational consumer, the goal is to obtain maximum satisfaction given the limited income. In other words, a rational consumer always tries to maximize utility in the budget set. Assume there is a consumer with a well-behaved utility function, U, X, Y. X and Y are the quantities of the two goods consumed. Given the prices of the two goods, Px and Py, and the income M, we can write the equation for budget constraint and draw it on a graph. Basically, we can assert that the consumer's optimal choice must be on the budget line, because if it's below the budget line, it means that the consumer has not spent all income. According to the monotonicity of preference, the consumer can use the remaining income to buy more commodities and then obtain higher utility. So the consumer will spend all the income on the optimal consumption bundle. By making the utility function equal to a specific value, you can draw an indifference curve for a given utility level. A higher indifference curve represents a higher utility level. The consumer wants to achieve the highest indifference curve, but he is constrained by the budget. Consider an indifference curve which intersects with the budget line, such as U1. There are two intersection points, B and C. We can easily find that any consumption bundle between point B and point C is better because they locate on the upper right side to U1 indifference curve. Consider another indifference curve U3, which do not intersect with budget line. It is high, but unfortunately, none of the consumption bundle on U3 are affordable. Therefore, which is the best choice for the consumer? Consider an indifference curve that is tangent to the budget line, such as U2. This is the highest indifference curve that the consumer can achieve within the budget set. The tangent point is affordable, and all the other consumption bundles on the budget line are on the lower left side to U2. So the tangent point of indifference curve and the budget line is the optimal choice for consumer given the budget constraint. Two curves being tangent with each other means the slopes of these two curves equal. Recall that the slope of budget line is minus Px over Py, while the slope of indifference curve is minus Mux over Muy. Now, we conclude that at the optimal consumption bundle, X star Y star, Px over Py equals marginal utility of X over marginal utility of Y. It is MRS of X for Y equals to the relative price of the two goods. Usually, we can find the tangent point between the endpoints of the budget line, which means the quantities of X and Y are both greater than 0. If this is the case, the optimal solution is called interior solution. The consumer consumes two products at the same time. However, in some cases, the consumer only buys one product. For example, the graph here shows a special case, and the tangent point of budget line and the indifference curve, the quantity of y is negative. But we cannot buy a commodity in a negative number. So the optimal choice actually is y star equals 0. The consumer only buys good X. In this case, we call the solution is corner solution. To sum up, if there is an interior solution and the preference is well behaved, the optimal choice should satisfy MRS equals Px over Py. Because we get MRS by calculating the first derivatives of a utility function, so this condition is called first-order condition. Why is utility maximized when the marginal rate of substitution is equal to the ratio of prices? Let's look at the economic implications of this equation. MRS of X for Y is the quantity of Y that the consumer is willing to give up for one more unit of X. But Px over Py is the quantity of Y that the consumer has to give up for one more unit of X. If MRS of X for Y is greater than the relative price, in order to consume one more unit of X, the consumer has to give up less Y than he is willing to give up. So, buying more X can increase the utility level. The consumer's utility hasn't been maximized. If MRS of X for Y is less than the relative price, in order to consume one more unit of X, the consumer has to give up more Y than he is willing to give up. So consuming less X can increase the utility level. The consumer's utility hasn't been maximized neither. Therefore, only when MRS equals to the relative price, the utility level can be maximized. Then, combining the first-order condition with the budget constraint, we can find the optimal choice for the consumer. The solution is the demand for the goods, which depends on the prices of the goods and the income of the consumer. You should notice that first-order condition is only a necessary condition for optimal choice, but not sufficient. For example, as this graph shown, we find two tangent points of indifference curves and budget line. Both these 2 points satisfy first-order condition, but we can easily find that point A locates on a higher indifference curve. It's better than point B. So actually, to make sure the tangent point is utility maximized but not minimized, we need to examine second-order condition. But in this course, we only focus on the simplest case by assuming that the preference is convex. It is MRS is diminishing. So we always find only one tangent point, if there is one. The optimal choice is the quantity of consumer demand at given commodity prices Px, Py, and income M. When the prices and the income change, the optimal choice will also change. The function of optimal consumption related to prices and income is called the consumer's demand function. Different preferences lead to different demand functions. Let's take Cobb-Douglas preference as an example to see the demand of a consumer with a well-behaved preference. Recall the Cobb-Douglas utility function. Its general form is U equals X to A times Y to B. Given the commodity prices Px, Py, and income M, we get the consumer's budget constraint. According to the first-order condition of optimal choice, MRS should equal to Px over Py. Let's calculate MRS by marginal utility of x over marginal utility of y, which equals to Ay over Bx. It equals to the relative price. And then combine the budget constraint. By solving the two unknown variables of these two equations, we can obtain the consumer's demand for x and y. Let's try to solve the equations together. Rearrange the first equation, we get Bpxx equals to A Pyy. Then Pxx equals to A over B times Pyy. Now we plug this result into the second equation. Get A over B Pyy plus Pyy equals to M. By rearranging it, we get Pyy equals to B over A plus B times M. So Pxx equals A over A plus B times M. Observe the results. The left side, Py times y, is the total expenditure on y. Similarly, Px times x is the total expenditure on x. The results show that for a consumer who has Cobb-Douglas preference, the optimal expenditure on each commodity takes a fixed part in his total income. And the proportion he spends on each commodity depends on the two powers in the utility function. Let's continue to rearrange these two equations to find out the demand function. Therefore, we can easily use the property of CD utility function to obtain the demand functions. For instance, a utility function u equals to x squared y cubed. The demand function must be x equals to 2/5 times m over px, and y equals to 3/5 times m over py. Now, let's look at another example. Perfect complements. The utility function of the perfect complements is u equals to the minimum value between x and by. The indifference curves are L-shaped curves, so we can't use the tangent condition to find out the solution, because a downward sloped budget line cannot be tangent to this L-shaped curve. However, according to the utility function and the indifference curve, we can easily find out that the optimal choice must be the inflection point of the indifference curve. For example, on an indifference curve, these two bundles bring the same utility level, but obviously bundle B costs more. So the optimal consumption bundle must be an inflection point and satisfy AX equals to BY. Consumers always consume X and Y with a fixed ratio of B to A. Combining this equation with the budget constraint, we can solve the consumer's optimal choice. The first equation shows X equals to B over A times Y. Plug it into budget constraint and rearrange the equation, we get the solution. For example, a utility function is U equals to the minimum value between 2C and S. C and S respectively represent the amount of coffee and sugar. According to the utility function, the optimal choice must satisfy 2C equals S, which means this consumer always would like to add 2 spoons of sugar to 1 cup of coffee. Given the price of coffee PC, the price of sugar PS, and the income M, we can write the budget constraint. Plug S equals 2C into budget constraint. We get the demand for coffee and the demand for sugar. The utility function of the perfect substitutes is U equals to AX plus BY. The indifference curves are straight lines. Because the consumer always substitutes X for Y at a fixed ratio, the negative slope of the indifference curve gives the marginal rate of substitution. We can calculate it by the ratio of marginal utility of the two goods. It results minus A over B. Given Px, Py, and M, the slope of the budget line is minus Px over Py. Now we need to compare the slopes between indifference curve and the budget line. If, as this graph shown, the indifference curve is steeper than the budget line, that is, MRS is greater than Px over Py, the highest indifference curve intersect with budget set on the x-axis. The consumer's optimal choice is to spend all the income on commodity X. For example, Amy would like to replace 1 bottle of Pepsi to 1 bottle of 7-Up. So the MRS equals to 1. If the price of Pepsi to the price of 7-Up is less than 1, it is Pepsi is cheaper than 7-Up. The optimal choice for Amy is only purchasing Pepsi. Oppositely, if the indifference curve are flatter than the budget line, MRS less than Px over Py, the best choice is on the y-axis, and the consumer spends all the income on good Y. In the third case, the slope of the indifference curve is the same as the slope of the budget line. MRS equals to Px over Py. And this time, the highest indifference curve that the consumer can reach happens to coincide with the budget line. The optimal choice is not unique. All consumption bundles that are on the budget line are optimal. Now we can write the demand function for the perfect substitutes. It's a piecewise function. In the first case, MRS larger than Px over Py. That's to say, Px less than A over B times Py. All the income is spent on X. The demand for Y is 0, while the demand for X is M over Px. When MRS is less than Px over Py, all the income is spent on Y. The demand for X is 0, while the demand for Y is M over Py. When MRS exactly equals to Px over Py, the demand for X can be any number between 0 and M over Px. Similarly, the demand for Y is any number between 0 and M over Py. In this lecture, we have learned the consumer's optimal choice and apply the conditions of optimal choices to Cobb-Douglas preference, perfect substitutes, and perfect complements. By solving the consumer's optimal choice problem, we obtain the consumer's demand function, which is a function related to income and the prices of commodities. In the next lecture, we will learn how the optimal choice changes when the income or the price changes. See you next time.